Welcome to another exciting episode. Today we're venturing to the Earth's core. Gaze at our planet from afar, beautifully floating in the cosmic expanse. Now, observe as it morphs before your eyes. Like a puzzle, the Earth splits, unveiling vibrant layers beneath. Each layer is unique, each carries a tale. We commence with the crust, the outermost layer, home to all known life. Subsequently, we explore the mantle, a dense layer of heated rock. Further down, we encounter the outer core, a pool of liquid metal. Lastly arrives the inner core, an iron-nickel ball at our planet's heart. Prepare as we delve into these layers, exposing their secrets. This isn't a routine journey, but an adventure deep into Earth's core. Now let the exploration begin. Imagine the Earth as a delicious layered dessert. The crust, our home, think of it as a thin layer of icing on a cake. Beneath that is the mantle. Picture it as a thick layer of gooey caramel. It's the most extensive part of the Earth, semi-solid and moves gradually, following the outer core. Envision it as a molten metal-like layer, creating our planet's magnetic field. And lastly, at the of our planet is the inner core. Imagine a glowing red ball, solid hot, with temperatures mirroring the sun's surface. Our Earth, a sweet and simple cake analogy of its intricate layers. Each layer, much like in baking, is essential for our planet's structure. Now, let's continue digging deeper into the wonders of our Earth. Now, let's put our new knowledge to the test with some real-life application. We're visualizing seismic waves from an earthquake traversing our model Earth. Watch as the waves radiate from the epicenter, marked by a bright flash. Observe the color-coded waves. Quick P waves are in red, compressing and expanding the Earth's layers. Notice them swiftly passing through all layers. Slower S waves are in blue, causing the ground to shake, passing only through the crust and mantle. Then come the green surface waves, causing most earthquake damage. Watch them ripple the crust. The change in color intensity represents wave speed changes. As they transition from crust to mantle, a color intensification signifies speed increase, while fading at the outer core indicates slowdown. This visual helps understand seismic waves and why we feel earthquakes. It's due to our Earth's layers' unique traits. Now let's move on to our final segment, where we'll explore more wonders of our Earth. Now, let's delve into the fascinating world of earthquakes, aided by the marvels of modern technology. As you gaze at the rotating Earth model, notice the large, irregularly shaped chunks on its surface. These are tectonic plates, constantly shifting and sliding past each other. As the Earth model zooms in, a product of advanced geophysical imaging techniques, you'll see an animation illustrating these movements. Can you see the tension building? This is the moment before an earthquake, a sudden release of energy in the Earth's crust. Suddenly, a flash of light erupts from the point of tension. This is the epicenter, the earthquake's birthplace. Watch as waves ripple outwards in a stunning visual representation of seismic activity. Feel the tremors? That's the power of an earthquake. With this understanding, let's also pay tribute to the remarkable drilling technologies, such as the Kola Super Deep Borehole, that allow us to explore deep into Earth's crust. Remember, the more we learn about our Earth and utilize these amazing technologies, the more equipped we are to protect it. Stay tuned, explorers. Now, let's delve into the mysteries that still remain about the Earth's interior. Even with our advanced technologies and extensive studies, there's still so much we don't know. Scientists around the globe are unceasingly trying to learn more about our planet's inner workings. They are investigating questions like, what is the exact composition of the Earth's core? How does the movement of tectonic plates influence life above ground? And what are the precise mechanisms that trigger earthquakes? But there are enigmas that elude us. For instance, we know that the Earth's core is primarily made up of iron and nickel. But what about the remaining elements? And how do these elements behave under such intense pressure and temperature? There's also the unsolved mystery of how Earth's magnetic field is generated and why it occasionally flips its polarity. These are just a few of the countless questions that make the Earth's interior such an enticing field of study. And who knows? Maybe one of you watching this video will be the one to unlock these secrets in the future. Maybe you'll be the one to advance our understanding of this amazing planet we call home. So keep asking questions, keep exploring, and most importantly, stay curious, bright kids. Next, let's delve into the world of myths and legends that have sparked imaginations about what lies beneath the Earth's surface throughout history. Before we move on to earthquake preparedness, let's take a fun detour and explore some of the myths and legends from various cultures about what lies beneath the Earth's surface. Our first stop is ancient Greece, where the underworld, a realm ruled by the god Hades, lay beneath the Earth. This was a place for the souls of the dead, a stark contrast to our scientific understanding of the Earth's core as a hot, molten sphere. Next, we journey to ancient China, where folklore tells of a giant called Pangu. He is said to have emerged from an egg, separating yin and yang to create the earth and sky. He then held up the sky, keeping it separate from the earth. Lastly, we delve into Norse mythology, where beneath the earth's surface lie the realms of dwarves and giants. Dwarves were skilled craftsmen responsible for creating many of the gods' magical items. Isn't it fascinating how our understanding of the earth has evolved over time? From a place of myth and legend to a scientific marvel that we continue to explore and understand. Now let's get back to science as we discuss how we can prepare for and protect ourselves during earthquakes. Stay curious, bright kids. As we've learned, earthquakes are a powerful natural phenomenon, born from the shifting and sliding of tectonic plates. But before we delve into that, let's explore some myths and legends about what lies beneath the Earth's surface. What can we do about earthquakes? How can we protect ourselves and our communities? This is where earthquake preparedness comes in. As the screen splits, one side shows an animation of a well-prepared city, while the other side shows a city unprepared for an earthquake. Note the differences. Prepared cities have buildings designed to withstand the shaking, emergency response plans in place, and citizens who know what to do during an earthquake. They drop, cover, and hold on. Unprepared cities, on the other hand, suffer greatly when an earthquake strikes. This comparison is not meant to scare you, but to emphasize the importance of preparedness. So let's take action today for a safer tomorrow. Learn about your local earthquake risks, make a plan, and build an emergency kit. It's time to shift our focus from fear to preparedness. Remember, knowledge is our best defense against natural disasters. Stay safe, bright kids. Now that we've learned about the Earth's layers and how they interact to create seismic activity, you might be wondering, how is this knowledge applied in real life? Well, explorers, buckle up, because we're about to take a ride through the practical applications of our newfound knowledge. On the screen, we see an animation of a drilling rig. Our first stop is oil and gas exploration. Understanding the Earth's layers is critical in locating and extracting these precious resources. Geologists use seismic data to create maps of the subsurface, helping them identify potential oil and gas reserves. Next, we transition to a bustling mine. Knowledge of the Earth's layers is equally crucial in mining. Geologists study the Earth's crust to find and extract valuable minerals. They analyze the composition and structure of rocks to determine the best locations for mining operations. Finally, we shift to an animated cityscape, showing a seismograph recording an earthquake. Understanding the Earth's layers also helps us predict and mitigate geological hazards like earthquakes and volcanic eruptions. By studying the seismic waves that travel through the Earth's layers, scientists can predict the likelihood of future seismic events, helping communities prepare and potentially saving lives. So, as we can see, understanding our Earth's layers is not just for the scientifically curious. It has practical and important applications in our daily lives. Knowledge is power, and in this case, it's also a source of energy, wealth, and safety. Stay curious, bright kids. As we move into scene 9 of our journey to the Earth's core, let's seize this moment to revisit some integral terms we've unearthed today. As our screen morphs into an engaging glossary, we commence with the mantle. The mantle, portrayed as a robust layer, finds its place between the crust and the outer core. It constitutes the bulk of our planet's volume, and it's the theater of most seismic phenomena. Transitioning upwards, we encounter the crust. This slender and solid uppermost layer of the Earth, illustrated as a fragile shell, is our current standing ground. It serves as the Earth's defensive layer, and it's the site where we experience the impacts of seismic waves. Turning to seismic waves, these are energy ripples journeying through the Earth. They originate from earthquakes, volcanic eruptions, magma displacement, grand landslides, and even substantial human-made explosions. As our glossary animates these waves, observe their motion and dispersion from the epicenter of the disturbance. Commit these terms to memory as they underpin our understanding of our Earth and its seismic activities. Hence, continue your exploration. Keep enriching your knowledge, and above all, maintain your curiosity, fellow explorers. Our voyage into the enigmas of the Earth persists. As we delve deeper into Scene 10, we'll shine a spotlight on the tools and techniques that aid us in comprehending our Earth's seismic activities. These instruments, as we'll see, function as our underground eyes, enabling us to perceive the invisible seismic waves we've just familiarized ourselves with. First up is the seismograph. This invaluable tool, depicted on screen as a sensitive device with a pen and a rotating drum, records the intensity, duration, and direction of seismic waves. Next, we encounter seismic tomography. In this method, portrayed as a series of cross-sectional images, we use seismic waves to map the Earth's interior, similar to how a CT scan works in medicine. Lastly, we encounter ground-penetrating radar. This technology, illustrated as a device emitting radio waves, helps us detect subsurface structures and anomalies. As these tools and techniques animate on our screen, pay close attention to their functioning and their contribution to our understanding of Earth's seismic activities. Remember, these are the keys that unlock the secrets of our Earth's interior, so stay tuned, keep learning, and continue this seismic exploration with us. And don't forget to like, subscribe, and ring the bell icon for more exciting adventures.